This is the Pearson Edexcel IGCSE Further Pure Maths Paper 1 from November 2021. The first question is all about roots. So here clearly alpha plus beta is minus 3 over 4, which is plus 3 over 4, and alpha times beta is minus 8 over 4, which is of course minus 2. So we set up those as usual, and then we'll start thinking about this stuff over here. So if we have some kind of quadratic, ax squared plus bx plus c, that means that 1 over alpha plus 1 over beta, if those are the two roots, 1 over alpha and 1 over beta, if you add them together, you're going to get minus b over a, just like we set up here, kind of for this one. And if you times them together, you're going to get, so 1 over alpha times 1 over beta will be c over a, which I'll do in a second. But for now, let's combine these together, just doing, this is alpha times this by beta over beta, and this by alpha over alpha, you end up with this. And then, of course, we know alpha beta is minus 2, and we know alpha plus beta is 3/4. 3/4 over minus 2 is minus 3/8, and we end up with this, cancel the negatives, and we get that. Now I can set up that the two things times together must make c over a. So I can do that. Of course, that just makes this. Alpha beta is minus 2, so that makes this. And now how do I make, so like what I'm aiming to do here is say b over a is 3 over 8, and c over a is 1 over 2. Now I could just make a quadratic with like b being 3 and a being 8, right? That would work. Except a wouldn't be 8 here, but it would be if I just times this by 4. Right? And now I think I have something nice and consistent. I can use c as minus 4, I can use a as 8, I can use a as 8, I can use b as 3, and we end up with that quadratic there, which I think works perfectly fine. Number 2 then is just a discriminant check. B squared minus 4ac is greater than 0 for two distinct real roots. B is p minus 1, a is 2, and c is minus 2p, which gets you this. You expand all this out properly to get this section, and then this just gives you this. You combine these together. This doesn't factorize, so let's just get out the quadratic formula really quickly. Eventually we end up with all this. A calculator gets you this pretty quickly. Now we need to be bigger than 0. So the two critical values, so we've got our two critical values here, minus 7 plus 4 root 3 and minus 7 minus 4 root 3. If we're greater than 0, that means we need to be either side of the two critical values. So less than the small one and bigger than the big one. The small one is minus 7 minus 4 root 3, so we're going to need to be p less than that. And the big one is going to be the other one, and we need to be greater than that. So greater than 0, you need to be either side of the two roots. If this would have been a less than 0, we would be in between the two. But that's how we do those questions there. The area of a sector in radians is r squared theta over 2, and the arc length is just r theta. So therefore 16.8 is r squared theta over 2, as I just said, and the perimeter is r theta, the arc length, plus this r here. So that's going to be r theta plus 2r. Okay, this I can solve. Double this equation here, divide by r squared, put that into there. When you do r times this, one of those r's is going to cancel, you get left with this. Times everything by r to get here, rearrange that. It's another quadratic that might factorize, I guess, if I made it into some whole numbers, but otherwise I just shoved it into the quadratic formula. It got me this, so it did factorize, therefore, if you had tried really hard. R is a integer, so therefore 4 is the correct answer. And of course, if you have 4 as the answer, you can just put that into here to find theta, and you get theta is this, and that's question 3 done as well. Show this thing here. So I utterly refuse to do quotient rule at any point ever. So I'm going to write this as, obviously this is x squared minus 9 to the power half, because it's a square root. But of course, if it's on the bottom, then it's to the power minus half if I want to write it like this here. Now I can just do product rule. Differentiate this one for 2 cos 2x, leave this one alone. So that's there. And then leave this one alone and differentiate this one. The minus half comes to the front. The derivative of this is 2x, and then this stays the same, drops down to a minus 3 over 2. And we have this here. Now to get it in this form, I've just got a bit of work to do. So I'll do that, I guess. You can write, obviously this expands out. I've expanded this, these 2's cancel here, get a minus out to the front here, so that's all fine. This I can put down to the bottom, and likewise this here to get rid of the negative powers. This of course is just the root of this, and this is the root of this all cubed. But what I want to do is put these together. So if I times this one by x squared minus 9 to the power 1, top and bottom, I end up with this. And obviously this times to the power 1, add the powers to get 1.5 there. This would of course cancel down to this, because that's power 1, 1 minus 3 over 2 is a half, down at the bottom here. And now we can combine the numerators to get this, which is looking pretty accurate. And then of course this denominator here can just stay the same, except I've written that as this to the power half to the power 3, because of course you would multiply these powers when doing this, which would give you 3 over 2. And this to the power half is just the square root, and so we'll end up with what they want us to get. I guess I haven't actually written that in exactly that way. I think I'd get 4 marks for this, but I should have done this the other way around, shouldn't I? I should have put the 3 here and the half here, and then it's the square root of the entire thing cubed. So let's just pretend I did that. I put the 3 here and the half here. Of course, it doesn't make a difference because you're just multiplying stuff, and multiplying is commutative. Doesn't matter which order you do it in. So put the 3 here, put the half here, and then the 3 goes there, and then you have the square root of the entire thing, and you end up with this, which I guess I should have written, but it doesn't really matter. When you have logs of two different bases, you want to get out the log law, the perfect, amazing log law here. Log to base a of b is log to base whatever you want. We all want Taylor of b over log to base whatever you want, as long as it's the same as what you had before, of a. So this number goes there, this number goes on the top, and then just whatever base you want goes in here. So I think I'll keep this one the same. I'm going to write x minus 5 rooted to the power half instead, of course. You can see what I'm about to do with that, I hope. And then this one here, I'm going to write as log to base 3. I'm just choosing 3 because I just want to, of this thing over log to base 3 of that one there. Log to base 3 is log to base 3 of 9 is is 2, so dividing by 2 is the same as times by a half. This half can come out to the front here. I can factorize out a half, I guess, and then just say these two logs now have the same base, which means I can follow log laws and just multiply the two inputs. So this is going to be a half log to base 3 of this times this, and then I can move the one to the other side, double everything, raise everything, 3 to the power both sides. We'll cancel out this log and do 3 to the power 2 is 9. And then, of course, expand this out, move the 9 to the other side, factorize that again, and you get x is either 6 or minus 4. Except if x was minus 4, you'd have to take log to base 9 of minus 1, which you can't do. You can't put a negative inside of a log, and so therefore x equals 6 is going to be our only answer. Now, question number 6 then. The volume of a sphere is increasing at constant rate 3. So dr by dt is 3. That's the first thing. Sorry, dv by dt is 3. The volume of a sphere with radius r. So dv by dt is 3. Sorry. Find the rate at which the surface area is increasing. So we want dsa, if I'm calling surface area sa, by dt. We want that when r is 10. So that's what we're going to try and find. Now, how have they possibly given us enough information to do this? Well, we know things about the volume and the surface area. We know volume is 4/3 pi r cubed. I haven't actually checked. Maybe that's in the formula book. I don't know. dv by dr, just differentiate this with respect to r, you get this, which is actually the same as the surface area of a sphere, which is interesting and not a coincidence. But anyway, dsa by dr is therefore this, just differentiating again. And now I want dsa by dt, and I think I can very intelligently get that with all of this stuff, because I could write dsa by dt as dr by dt times dsa by dr. These dr's would cancel and just leave me these two terms, so that's going to be the same thing as this. Right, so that's the first thing I'll do. Now this isn't that helpful because I don't need to know dr by dt. However, I think I can also write dr by dt as like dv by dr times, or like this, really, dv by dt times dr by dv. And again, it just takes some thinking through as you're writing this out just to get this right, but these v's would cancel and just leave me with dr by dt, and then this has stayed the same. But dv by dt, I think I have, it's up here. Dr by dv I have if I just flip this out upside down, so that can go there. dsa by dr I have, it's here. So I have all three of these things. So let's just multiply them all together. We get this when some other stuff cancels. And all I'm doing is evaluating that at r is 10. And so we get 6/10, which is 0.6 as our answer. Quite a nice question. Question 10 then, so just doing cosine rule to start with. K squared is equal to 8 squared plus 6 squared minus 2 times 8 times 6 times cos theta. Rearrange that, and eventually you'll end up with exactly what they wanted you to get, so that's fine. The area is this, so therefore half times 6 times 8 times sine theta is this thing here. So double this and then divide by this, you get this. I think, yeah, sure. And then we can, of course, use cos squared plus sine squared equals 1. Rearrange this, take away sine squared from both sides and square root, and we get this. Remember the plus or minus, that's going to be important for this thing here. So now we can take this equation here and substitute this result into here for cos using this as sine. So sine squared is just obviously 445 over 24 squared, which is this. Put that in there, which then, of course, can go in here, and we get this result here. I think this actually tidies up really nicely to this, which is nice. You know you're onto the right thing here because root 121 is 11, root 576 is 24. Of course, times by 96, we get this, and then we can move the 44 and the k squared over each way. 100 plus 44 is 144, square rooted is 12, and then take away is 56, square rooted is this. But I think it told you, oh no, two possible values. Those are the two possible values, I guess. And we'll be done here, I think, with our answer. Good, a nice little vectors question here. you need to use properties of regular hexagons for this. And it's kind of unusual in that respect, that usually the vectors are just enough on their own. But here we do need to think about the properties of regular hexagon. So O to B is clearly just A plus B. Good, that's our free mark this paper. Now I immediately ask for B to C, and we actually can't do this just with the vectors. What we need to think about is this regular hexagon here. I mean, the answer, well, the answer is we're going to say that this vector across here is just 2b. Now, how do I know that? Well, it's parallel to b, clearly, so it's definitely some amount of b. How do I know it's exactly 2? Well, let's just get out a regular hexagon with sides 1, and think about the length of this side here. Now, if we drop a line down here, a regular hexagon has interior angle 120. So this angle here is 60, because I've just cut it in half. And this angle here is also 120. This is a right angle, which means this is 30. And now this length here, I mean, this is a right angle as well, so this would be 30 anyway. But this length here, I can just get by doing cos 60 is adjacent over hypotenuse, so x over 1. Cos 60, this should say cos 60, apologies. That's just a typo. This should say cos 60. Cos 60 is adjacent over hypotenuse, so that's cos 60, which is root 3 over 2, sorry, which is a half. This is just all wrong. This should say cos 60 is x over 1. Cos 60 is a half because it goes down, yeah. Cos 60 is a half, so x is a half because x over 1 is x. But of course, you can do the same thing over here and actually do it right this time. And you get a half here, and 1 in the middle here, of course. A half plus 1 plus a half is 2, so therefore this length is 2, and that's just 2b. And of course, once you've got that, b to c is just minus a plus b plus 2b, which is minus a plus b. And that will be that done. Apologies for the mistake there. The point M divides BC in the ratio of 2 to 1. This just irrationally annoyed me. M should be the midpoint, right? It's dumb that they called that M and it's not the midpoint. But anyway, it doesn't really matter. This is ratio of 2 to 1, which of course means you can just divide this by 3 and times it by 2 to get, it's just 2/3 of this, right? It also annoys me a little bit. They haven't told you whether M divides it. Like, maybe it's implied. I'll be willing to accept if that it's possibly implied. But 2 to 1, I think I could argue that they haven't told me whether it's 2 to 1, 2 and then 1, or 1 and then 2, and it should be up here somewhere. Like, they haven't actually made that clear. And maybe the fact that it's B to C, maybe that's enough to imply it. I don't think it is, to be honest. I think they should have said it. B to M is 2, M to C is 1. Like, that's how they should have written it. So I was a bit annoyed about that, along with the annoyed about this being M thing when it shouldn't be. Anyway, I try and do these videos quite quickly, and I've just massively wasted time. O to M is clearly just A plus B plus this thing here, which simplifies to that thing there. The point Y is such that OMY and ABY is straight lines. This is interesting. So ABY is a straight line, so Y is up here somewhere. And OMY is also a straight line, so it's over here, where those two things meet, somewhere over here. That's pretty cool. Use a vector method to find AB to BY. Okay, well, we just need to find a couple of roots here. So what I first started talking about was A to Y is clearly just KB because it's a straight line, right? So K is some number bigger than 1. You just multiply B up by some number, you get all the way to Y. So that's fine. And another way, though, of describing A to Y, though, we could say it's minus A plus O to Y. So A to Y, I can say is minus A, going backwards along here, plus O to Y. Now, O to Y is just O to M, which we worked out here, times by some other scalar factor, which I'll call M, little m here. So that's my two ways of describing A to Y. Of course, they're equivalent because they're doing the same vector. So therefore, well, I need to simplify this one up a bit to get this. So that's in terms of A's and B's. Therefore, this thing here, a third m minus 1, that must be 0 because I know AY doesn't actually have any A's in it. So this must be 0, which means I can solve for m as very quickly as 3. And then these two things here, 5/3 m and k, they must also be the same. M is 3, which means k is 5. And so therefore, this vector here is 5b. So this is parts 1 to 4, because the total is 5, so it's 1 to 4 there. This question is kind of interesting. I don't think I've done this in a very intelligent way. I think there's probably a really beautiful way of doing this that I just couldn't see. But another nice thing about regular hexagons is they're just 6 equilateral triangles. 1, 2, 3, 4, 5, 6, like all drawn from the center. And you know that because, of course, the interior angle is 120, so when you halve it, you get 60. and then you just get 60 and 60, 360 divided by 6 is 60, so this is also 60. So yeah, they're all just nice equilateral triangles. And so what I decided to do was I said, well, okay, if the total area is 60, that means each of those equilateral triangles is area 10. So I said, okay, this area is 10, this is equilateral, so we've got sides x and x. I'm just considering what regular hexagon has area 60. And so call the sides x and x. This area is 10, as I've said. So a half times x times sine 60 is 10. Sine 60 is root 3 over 2. So that's root 3 over 4 here, times by 4 divided by root 3. And we end up with x squared as this. Now, how is that helpful? Well, we look at this up here, and we go, okay, I can just call this length x and this length x, for instance. And therefore, this length here is 5x, as we talked about before, with k being 5. So I think the area of the triangle OAY is half times x times 5x times sine 120. And of course, x times x is x squared, which I'll replace this with this object. 5 over 2 is there. Sine 120 is root 3 over 2. We replace the x squared with this thing here. These cancel. 40 divided by 2 is 20, divided by 2 is 10, times 5 is 50, and we'll have our answer there. There's probably much more elegant ways of doing that, but I just couldn't see it. Anyway, show that this thing is this. So this is a sequence that starts r is 1, so the first term is 4, and then you add, when r is 2, you get 5 times 2 is 10 minus 1 is 9. So it's 4 plus 9 plus 14, and so on. So this is an arithmetic series. First term 4, so a is 4, difference of 5. We can just use this formula here. So the sum of n terms, just put n over 2 times 2 times 4 is 8, and then d is 5. Simplify that up, and you end up with this, which is what they wanted. So that's good. Hence, we'll otherwise evaluate this. So this is just the sum from 1 to 20 minus the sum from 1 to 9. So just get rid of the first 9 terms to so that it's as if you started at 10. But of course, both of these, this is just the sum. This is just S20, right? The sum up to 20, and this is just S9. But we can evaluate both of those using this little thing here and type in a calculator, and you get this here. This is really weird. Essentially, this line is just telling you you're still looking at this sequence here. It's really weird. I think they just wrote this to confuse you, but they're just telling you that you're still looking at the thing you were looking at before. I was a bit weirded out by it, but anyway, the rth term is this. Now the rth term, just be clear, like the first term is a, then it's a plus d, then a plus 2d. So the third term is a plus 2d. So therefore the nth term is a plus n minus 1d, right? Like it's always one less than the term number. So first term, second term is just 1d, third term is 2d, fourth term is 3d. So therefore the rth term is just a plus d times r minus 1. Like you're always one less. And I'm using the a and the d that we already know that we had up here. So okay, that's ur, which of course means un plus 1 is just, you just put an n plus 1 in here, and you just end up with 5n, right? So then we can just use the Sn formula that we had before, which is this one here. We can use 12 times this here with r is n plus 1, which cancels this one. You just get this. Then you just add 52 on the end. When you solve this, I mean, this is now just solving equations, right? That does factorize apparently, but I didn't spot it, so I just put it in the calculator and got these two answers here. N has to be a term number, so it can't be minus 1.6, so it's therefore 25. And we have our answer to this question. Question number 10 then, I'm going to make this complaint right at the start, and then I promise not to bring it up again. This question had the potential to be really good, a really good challenge of lots of different pieces of knowledge and stuff like that. And it's not, because this is a calculator over. And so literally all this question is just, can you type buttons on a calculator whilst having some pretty basic knowledge of maths in the meantime? And I'm really annoyed about that, because there's no need for that to be the case. And it's really stupid and really dumb. I promise that's the end of the complaint. Show the coordinates m of this. So these are roots, right? M and n. So y is 0, so put y is 0 in. Take away half from both sides, do sine inverse in a calculator. You get this. At least that's what my phone gave me. I'd be interested to know what a proper calculator gives you. But my phone gives me minus pi over 6, which is what it thinks is the principal solution. Of course, I'm not interested in that, because that'll be over there somewhere. So what I want is this solution over here, which is pi plus pi over 6, which is 7 pi over 6. Or this one here, which is 2 pi minus pi over 6, which is 11 pi over 6. Divide those by 3, don't care about this one anymore. We get this. So that's the one for m here. and this is the one for n, so there we have that. Find the coordinates of a, that's the turning point, so we want dy by dx is 0. dy by dx is this goes away, 3 cos 3x will be that. We want that to be 0, of course. Divide by 3 does nothing, cos inverse is pi over 2, and divide by 3 and get pi over 6. Don't care about the other solutions to this because we're just looking for the first one here, which I think will be pi over 6. So x is pi over 6. We've got to find the coordinates, so we're going to put pi over 6 into here. And we'll 3 times pi over 6 is pi over 2. Sine pi over 2 is 1, plus a half is 3 over 2. And we'll have that there. Find the equation of tangent to c at m. So that's like a tangent line like this. So we want the gradient at m. We have the gradient function. So let's put the coordinates of m in there. So let's put that coordinate in there. We get this from a calculator. So now we can just do y minus y1 equals m x minus x1. And we'll have this. You can do a bunch of multiplying and stuff like that to clear all this out. You'll eventually do some algebra and get this. It's not that hard. The finite region shown in figure 4 is this. So these two regions here, they want to find both of them. So we've got a couple of things to do here. Firstly, we can't just integrate between 0 and 11 pi over 18, because then this negative area would cancel with this positive one. So we need to integrate between 0 and 7 pi over 18 of the curve. And then I'm actually going to take away the integral between 7 pi over 18 to 11 pi over 18. The reason I'm taking away is because this integral I know is going to give me a negative number, because it's underneath the axis here. So if I take away a negative number, I'll be adding it in. So that's why I've just done there. Anyway, we can do both integrals here, not hard integrals to do. Sine integrates negative cos, put the third here to obviously offset the 3 that would differentiate it down. Again, you can just, I've done a lot of work here. It's completely pointless because you can just type it into a calculator. Eventually you get that. Cool. I hope we're happy. Question number 11 is this here. So we have x minus 4 is a factor. That means f of 4 is 0. And x plus 1 has a remainder 25. That means f of minus 1 is 25. We can integrate this to give us this. Raise the power divided by 3, raise the power divided by 2, raise the power, add a c, of course. F of 4 is 0, so just make this 0, and these are 4s. We get this. F of minus 1 is 25, so make this as 25, make all these minus 1s. We get this. We can sort out both of these things. I think I'm going to times everything by 3 at the same time. Rearrange that maybe slightly to get this. Times everything by 3 here as well, and sort some stuff out. Take away 9, we get this. And then, of course, we can do this one, take away this one. This minus this is 390. This minus this is 65a. This minus this is 0. Divided by 65, we get this, which is what we wanted. We can also then infer that c, if that's 6, add 6 to both sides, divide by 3, and we get c is 24. So that's good. We have our equation for f of x is this here. Good. Hence, use algebra to solve f of x equals 0. So set that to be 0. I know this factorizes to x minus 4 because x minus 4 is a factor. It's literally a factor. So this factorizes with an x minus 4. I don't know what the rest of it is. You can do polynomial division if you want to, but everyone knows that I refuse to do that. All you have to do is say to get an x cubed, you do this term times this term. I want 2x cubes, so this must be a 2. To get plus 24, you do this times this. I've got a minus 4, which means this must be a plus 6. Sorry, a minus 6. 2 negatives, of course, multiplied to make a positive. What about this term here? If we just call it plus c for a second, we can then say that to get x squared terms, which I have minus 7 of, I could do either this times this to give me minus 8 of them, or this times this to give me c of them. So minus 8 plus c must give me minus 7, so c is 1. And we'll have a factorization here. This factorizes, of course, by doing some normal key stage 3 math stuff. You get this. Solutions are at 4, 3 over 2, and minus 2. And that, I hope, is the whole paper. I'll see you next time.